All right, so last time we left off, started talking about objects in Java, and this is going to be like our transition from just Java basics into object-oriented programming. Reminder that the last two recordings have failed. We had some tech people in here just a while ago looking at it and trying to troubleshoot it. So hopefully the issue is resolved. But again, remember that that it's not a substitute for watching those pre-recorded videos, which of course are guaranteed to be there, or coming to class and taking your own notes, because I can't guarantee that it won't fail again. Right? But hopefully it will. The issue is resolved, and the remainder of the lectures will be available on YouTube and VidGrid. So what we were doing last time, we were designing an airport object. In particular, an airport class in Java. And we identified that, well, an airport has a name, a GPS ID like LNK or OMA or whatever, a latitude and a longitude location, right? And it might have some other things that we'll come back and maybe redesign this or add on to it. But to demonstrate, I created two airports. Now, first of all, the airports are created with this new keyword, right? If you want a new airport, you go new airport, and then this looks like a function, and we'll talk about that momentarily. It's actually a constructor function. But what we did was we wanted to assign the name to Lincoln Municipal Airport. We wanted to assign the GPS ID to LNK and the latitude and longitude. Same thing for Omaha here. What I was using was the dot operator. Again, Java is a class-based object-oriented programming language. That means effectively that everything in Java is a class or belongs to a class. Now, if in the case that the thing that you're using is a class, then that means that you can create or instantiate instances of that class. And that's what I've done here. Lincoln is an airport. Omaha is an airport. O'Hare here, however, is an airport, but in my code here, it's uninitialized. I have not instantiated it. If I attempt to print anything out about O'Hare here, like its name, O'Hare, right? Well, what value does that have? In fact, it's not even letting me compile this. Why? Hopefully you can't. Maybe you can't see it, but it says that the local variable O'Hare may not have been initialized. That's exactly what I set up here. It's uninitialized. So what value does it have right here? Well, as far as a line 20 is concerned, what is O'Hare, the variable O'Hare, referring to? Null, exactly. If I print it out, you'll see that, right? Name, you'll see that it's actually null, or not name, sorry, but O'Hare. There we go. And again, it's not even going to let me do that because it's an uninitialized variable. It says, you know, the local variable O'Hare may not have been initialized. So it's already, the compiler is smart enough here to see that it's that I didn't set this anything to, so how can I print out any of its attributes? Normally, if we print it out, like say system.out.println, right? Say Omaha, right? That is initialized, and it will let me print that out. But when I print that out, remember I get this gobbledygook, right? That is the memory address of the objects being stored in the Java virtual machine memory. Well, O'Hare was uninitialized, so I can't even print out the memory address because it's not referring to anything. It's pointing to the null pointer, basically, the null reference. So you can also have uninitialized objects. But when you create them using the new keyword and a constructor, then you've instantiated an instance of it. The other part is, or it belongs to a class. And that simply means that everything, if it's not a class, like say an integer or a double, then it belongs to a class. For example, latitude or longitude. That belongs to this class right here. So how do I get it so that I can print it out? I have to use the dot operator. If it had a method, like math.square root, right? I use the dot operator to access the method so that I can call that method. So be aware that, again, everything in Java is a class or it belongs to a class, and the consequences of doing that you have to instantiate, you have to create these things. Okay? So let's go ahead and go back to our design here, and I'm noticing a lot of repeated code. Remember the DRY principle. DRY stands for Don't repeat yourself. So if I've got, this chunk of code is basically the same as this chunk of code. And by the way, this chunk of code is the same as this chunk of code. And if I did it for O'Hare, I would have to copy pasta. Don't do that, right? Copy pasta leads to what type of code? Spaghetti code, exactly. Incomprehensible mess that is intertwined with each other, and you can't make heads or tails of it, okay? So the first thing I'm going to do here is I'm going to create a constructor. So in Java, a constructor is very, very special. It doesn't, it's a very special type of method that doesn't return anything. Normally, you would have, say, public int foo, and then you would return 10, right? Because this is the return variable right here. And I have to return an integer. But a constructor implicitly returns the type of object that you're constructing, in this case, an airport. So we have different syntax. You don't have a return type at all here. The constructor has the same name as the class that you're trying to construct. Right? This is a no argument constructor. Right? This is the constructor that I was calling before. Right? The constructor I was calling before, I didn't pass in any parameters. This one doesn't take any parameters. It would be like if I didn't write that at all. It's like a lawyer, right? If you can't afford one will be provided for you. If you don't write a constructor, one will be provided for you. The default no argument constructor that ends up assigning null to all of the objects and 0 to all of the numbers, right? As we observed last time. I don't want that though. What I want to do is I want to take a page from last semester when we talked about factory functions, right? You want to create a structure. Well, you can go ahead and copy and paste a bunch of code to do that, that sets up memory, that does a bunch of other stuff, and copies strings, etc. Well, if you're going to do that over and over and over again, like we're doing here, take that code and put it into a method so you can call that method. This method is going to take each one of these things right here. String name, string GPS ID, double latitude, double longitude, and I'll go ahead and be content with a very, very long line here, okay? Now, the second that I do that, you observe that there's a problem in the other class. That old constructor, no argument constructor, has magically gone away. Because if you can afford a lawyer, you will be paying for it for yourself, right? And if you write a constructor, that no argument default constructor goes away. You can always restore it. Public, airport, and then to do, right? Implement this. Right? The magic to do that you don't have, it's the programmer's procrastination tool. I'll come back to it when I want to, right? So now this is magically restored over here. It doesn't do anything, but it's not causing a compiler error over here, okay? Now, maybe you don't really want that, so I'll just leave it. I'll go ahead and get rid of it for now. But if you want a no argument constructor and another constructor and 50 different types of constructors, you can do that. Unlike C, where you can only have one function with a particular name, so if you create a square root function, sqrt, you can never create another square root function. That had implications with your basic libraries, right? How did you take the absolute value in Java or in C? It depends, right? It was in the math library. You had abs, which was good for integers. What was good for floating point numbers, doubles and floats? You had to call it fabs. You also had labs, labs, and you had like a dozen different absolute value functions, all of them with different names. Because you don't have function what's called overloading. And that's something that we'll talk about in detail when we look at polymorphism. Here, you do have function overloading. So I can have, it's perfectly happy to have two different functions with the same name, airport and airport. It knows the difference because one of them takes no arguments and the other one takes 4 of them. So over here in airport demo, when you call this constructor that takes no arguments, the compiler knows, Java knows, oh, you probably meant to call this function and not this function. Right? It's not going to confuse those two because they differ in the number or types of arguments that you give it. Okay? Obviously, though, I could not have 2 functions with the exact same signature here. That will not be allowed because now it doesn't know, well, which one do you mean, right? They're named the same. They take the same parameters. I can't the compiler can't distinguish between these two, right? So we'll only have one for now. What I want to do is I want to set this object, I want to instantiate this airport, say over here I want to instantiate Lincoln with Lincoln Municipal Airport. I want to instantiate Omaha with Omaha Epley, right? I want to set this object's name to the parameter name. Right? I want to set GPS ID to the GPS ID that's given as part of the parameter inputs. I want to set latitude to latitude, and I want to set longitude to longitude. Right? Now you'll see a lot of squiggly yellow right there. Those are all warnings. Let's hover over there and find out why. The assignment to a variable has no effect. Right? To understand what it's talking about, let me go ahead and create a variable here, and I'll set it equal to 10. Right? Ignore what's below here. Look at what I'm going to write on line 15. X is equal to X. Would you ever write code like that? Hopefully not. Why? What is it doing? Let's read it. Take the thing on the take the value stored in the variable on the right-hand side and put it into the variable on the left-hand side. Okay. Right? Then what? Take this thing out of the box and then put it back in the box. Right? That's what that's doing, and that's the same warning there. The assignment to a variable X has no effect. All you're doing is taking the value in the name variable on the right-hand side and placing it into the variable on the left-hand side. That code has no effect, right? And that's because we actually have two variables in the current scope with the name, right? We have this variable up here, name, and then we've also got this parameter variable right here. And if you don't qualify it any further, then what you're basically doing is referring to this parameter variable. You're taking the parameter variable and placing it back into the parameter variable. Right? You're taking the value stored in this variable right here and simply putting it back into that same variable. I want to take this value right here and put it up into this member variable up here. So I need a way of distinguishing between those two things. One way is I could say param name, right? And now I can say the name this name up here is equal to the parameter name. That really messes up your code, though, doesn't it? Placing param in front of everything, that sounds icky. Right? Call things what they are, name and name. I need a way to distinguish between these two things. Okay? Now, to understand the next keyword that I'm going to give you, let's come back outside the class. We're outside the class now. This airport that I've created, Lincoln, I have a way to, here's the object that I'm holding in my hand right now. Just think about it in concrete terms that here's the Lincoln Airport, right? I'm able to take the Lincoln Airport and put it into my hands right here. How do I refer to that airport in this class right here? I call it Lincoln, right? So here's my reference that I'm pointing to this airport right here, Lincoln. Let's go back into the class now. So I'm following this reference and I'm jumping into the class. Now I'm inside the class. I'm inside the airport. How do I refer to this airport that I'm now at? I use the this keyword, right? Now I'm inside the airport. How do I refer to this airport? Well, what's the pronoun? I don't know if it's a pronoun or not, but how did I refer to this airport? With the this keyword, right? Now I'm able to disambiguate between these. I'm taking the parameter name and I'm placing it into this airport's name. Likewise, I can do the same with the rest of it. Quick shortcut here. This dot. Oops. This dot. There we go. Remember, how did I do that? Code block mode. Mac, it's going to be Option Command A, Alt Shift A in Windows, right? Now this is completely disambiguated, and now it has effect, and all that yellow garbage goes away. Now I can start using it. Instead of using this default constructor here, I can go ahead and give it all of my parameters now. Much improved. LNK, and then 40.9, and 96.75. And I have constructed an instance of an airport, and it's Lincoln. Okay. Same thing with Omaha Epley here. Let me go ahead and refactor that, change it so that the functionality is the same, but it's now taking advantage of new code that constructor that I just made. Okay. There. Much better. Right. Okay. So a little bit of a review here. In Java, objects or instances of classes, that is, another word for this is objects, can be created by using a constructor. Right. By default, a no argument default constructor is provided by the language. The moment if you define your own constructor, the default constructor goes away. Right? You can define any number of constructors. Right? For example, maybe I don't want I don't know the GPS ID. Maybe I'll go ahead and let's say copy pasta here. I shouldn't be doing this. But maybe I don't want the GPS ID. I just want to create an airport with a name and a latitude and a longitude. Right? It's not registered with the FAA yet, so it doesn't have a GPS ID or something. Right? It's Area 51. Right? It has no GPS coordinate because you can't go to it. But it has a name, Area 51, and it's in Nevada somewhere, whatever. Right? You can have as many different constructors as you want. Right? I copy-pasted there, but it seems like I don't want to do that. Let's roll back here. One criticism of Java is that it's verbose, meaning that you have to write a lot of boilerplate code to get stuff done, right? Well, that criticism kind of goes out of the window if you know how to use your IDE properly, right? For example, so I can't show this on the screen here because my taskbar or whatever it's called, my file bar here is on my other screen. But what I'm going to do is I'm going to go up to, follow along here. You can go up to source. You can generate constructor using fields. And it looks something like this. And what I wanted was a constructor that took the name, the latitude, and the longitude and assigned everything for me. Generate. Done. I didn't have to type a single line of code. I used my IDE to auto-generate some of this code for me. Don't worry about that, though. Right? It's OK to leave it there. It's OK to not have it there. It's auto-generated. I'm going to go ahead and get rid of it because I don't want to talk about it yet until we get to inheritance. Okay? So use your IDE to its fullest. Now I've got 3 different constructors here. Right? You can always go ahead and go back and get rid of them if you want. Okay? You can define any number of constructors. Use your IDE to its fullest. Right? And again, the way that I did that is in Eclipse, use source. Then this is going to render on, then I'll do it like this. Then source, then generate constructor using fields. Right? And that gets you there immediately without having to type any code. You can point and click stuff and then hit enter. Right? And that's what I've done here. Okay. Now what I'm going to do, I should have restored. I shouldn't have gotten rid of it, but I had the other. It's right here, encapsulation. We've basically done what we've already done in C last semester. We did the first part of encapsulation, the grouping of data together. Right? I've taken 3 elements and I've grouped, or 4 elements, I guess, and I've grouped them together to create a new thing, an airport. Right? Very, very useful, but in C, we did not have number 2, the protection of that data. And what I mean by that is, let me go ahead and, again, go outside the class. You can print it all you want, but you can also change it. Lincoln.latitude is equal to 4,000. Right? Is that a valid latitude? Latitudes go up to what? at the North Pole, it's exactly 90 degrees north, right? Yeah, 90 degrees north. So that's not a valid latitude. But I'm able to do that because these are all unprotected variables, right? So let me go over here and let me start protecting them. I'm going to go ahead and go into code block mode here, and I'm going to put a private in front of everything, okay? A private variable is something that can only be seen and thus modified by the class itself, okay? Let's go back over here to airport. The demo here, and you can see now that from the outside world, from this outside demo, I can no longer see Lincoln's name, GPS ID, latitude, or longitude, and consequently, I can no longer change it, right? Which is actually a very, very good thing. Up here, the constructors are unaffected. If you construct something and you give it these 4 attributes, then you basically have a guarantee, and you make them all private, you basically have a guarantee that that thing is immutable, like strings. Right? Remember that once a string is created, you can no longer change it. That is a very good thing because it ends up giving you for free thread safety. Right? But we do have to deal with the consequences here. Right? One of the consequences that I have to deal with is, well, I do want to print it out. Right? I'm not going to change it, fine. So this is no longer the case. I'm not going to change it, but I do want to access it so that I can print it out. That's where functionality comes in. I want to print out the name. Okay, I'll give you a public function to do that. Get name. Right. Return this dot name. Right. Now, in this case, where there's only one variable in the scope that has the variable name, and so I could get away without using the this keyword, but it's best practice to do so. Make sure that you're just doing it, right? Okay, well, that solves my problem as far as the name goes. Instead of directly accessing that variable, now I can do it circuitously in a roundabout way using the getNameGetter function. Right? All right, well, I want to do all the rest. So bear with me here while I continue to type 3 more getters. Yes? Or look for a better way. Again, source, and under source, if you're following along here, you'll see a lot of other generate functionality. Generate getters and setters is what I'm going to do here. Okay. Let me go ahead and expand these all out, and you'll see that every attribute has a getter, means that you can get that element, and optionally a setter. I'll go ahead and select all, and let's see what code it generates. Note here, however, that it's smart enough that, oh, you already have a getter for the name, right? Why? I don't need to generate that for you because it's already there. Let's generate everything. Ooh, hey, a bunch of getters and setters. Right? And now over here, I can refactor this to use get GPS ID, get latitude, excuse me, get longitude. Right? And now this will work. I'm going to comment this out for a second just so that we can compile and see that it works. Right? Lincoln Municipal Airport, LNK, et cetera, et cetera. Right? Okay. Great. Those getters, but maybe I don't have a need for setters. But here is why you may want setters. If you want to change the latitude, right, then what you can do is you can have, where is it? Get set latitude right here. Where is the set latitude? I thought I selected it. Find set latitude. There it is. Okay. Given this latitude, it resets this object's latitude to that latitude. Right? Now what I can do is I can control values. For example, if latitude is less than -90 degrees, or if latitude is greater than 90 degrees, then that is an invalid value to set this object to. Right? Some programming languages have value types where you can declare an integer that can only be 0 or 1. Or you can declare an integer such that this integer is not only an integer, but also the only valid values of this thing are going to be 0 up to 10, or positive values, or negative values, or non-negative values, right? You can set up constraints like that in some programming languages, not Java, right? C# comes to mind that they have value variables, right? It's not that common, though. It's kind of more of a, and it's honestly, it's not all that useful either, right? It's only very limited use cases that matters. So if we try to set this to an invalid value, what can we do? Basic error handling. How do we do error handling in Java? You gave me something bad, so I don't want this. What do? With a hot potato, you throw it back at them, right? We throw a new, I'll just throw an illegal argument exception. Again, you can use be a generic runtime exception if you want. I'll go ahead and throw a new illegal argument exception with the message that latitude is invalid. It must be between -90 and +90, right? Inclusive, because of course you can be at the North Pole, 90 degrees north. Right? And let me see this in action over here now. Again, I'm not able to set it directly, but I can call that setter, set latitude to 4,000. And this design has guaranteed me something. You can see the exception right there. With the message, 4,000 is invalid. It must be between 90 and -90 and 90, right? This design has allowed me to take back control. Remember, encapsulation, the second part, is the protection of that data. I have some guarantees here now. I have a guarantee that nobody can ever set this to an invalid latitude. And maybe you want to go back and say that, well, the name can never be null. So if anybody ever tries to set it to null, I can throw in an invalid value exception or whatever, right? In general, however, I don't like setters because I like immutable objects, and you should too. Because immutable objects give you thread safety for free, right? Just like strings are immutable. Big I integers are immutable. Doubles are immutable, right? So what I'm going to do is I'm going to roll all of this back. Getters are fine, but no, we're going to ban setters. Right? Again, it's a design decision. You ultimately, when you're writing your own classes, you have to decide: do I want this to? Do I want people to reset these values? Do I want to enable people to do that? Right? And if you've got a very good reason for allowing them to do so, then go ahead and do it. But we give them that option in the constructor. Right? Oftentimes, you'll find other patterns where, okay, we're going to ban all setters because all our objects are going to be immutable. Instead, what I'm going to give you is a copy constructor. Right? A copy constructor where maybe you want to change the latitude or the name or whatever. Right? Let me go ahead and give you what a copy constructor looks like here. Public airport. Now it's not going to take a name, a latitude, a longitude, or anything else. Instead, it's going to take another airport. And generally, I would call it A. But what I'm going to do is, for now, is I'm going to call it that. Right? I want to copy that airport into this airport. Why might you want to do that? If you are going to allow people to reset things, and change things. So in other words, this is now immutable, now mutable. Somebody can mutate it, somebody can change it. Before you go changing it, I want to make sure that I've got the original though. So this is a deep copy function, kind of. Right? What I'm going to do is this dot name is equal to that dot name. This dot GPS ID is equal to that dot GPS ID. This dot latitude is equal to that latitude. This dot longitude is equal to that dot longitude, and I screwed up. I missed one of the that. All right, there we go. A deep copy, so that if you ever do allow somebody to make changes to your objects through an intentional design choice, well, then you may also want to give them the opportunity to have a copy constructor here. And by the way, you can get really creative. Right? Maybe you don't want just a copy constructor, but you want a copy and change constructor. For example, I want to allow you to change the longitude. So double longitude. Again, I don't know why you would want to do this. It's you're physically picking up the airport and moving it east and west a little bit. I don't know. But instead, what we can do is we can copy everything except for that longitude, and we'll take this new longitude value instead. Right? And this is it's not called an impure copy constructor. It's weird to call things impure. This is a pure copy constructor, and that's a perfectly fine name. But this one, you don't call it an impure it's not tainted in any way or anything like that. Instead, it's maybe a hybrid copy constructor or something. I don't know if there's a standard name for this kind of stuff. Right? But you can end up changing the values. You can copy any subset of those values with the opportunity to change them. And that might come in handy with your project that you'll be starting next week. Okay? So those are a bunch of constructors. And again, I got rid of my setter here. So what I can do is, I don't know, airport moved Lincoln. There we go. Is equal to new airport. And then we'll go ahead and set it to Lincoln. But then I'll change its longitude to, I don't know, 80 degrees instead of 40 degrees. So we're moving, it's probably in the middle of the ocean, but whatever. And then we'll go ahead and print it out. All right? And to see that this actually occurred, system.out.println moved Lincoln. All right? Latitude, longitude, so I moved it, let's see, I would have moved it west, and it's probably in the middle of the Pacific Ocean at 80 degrees west or something. Right. So when I go ahead and try to do this, something's going to happen. Right? There's the original Lincoln Municipal Airport. It's still at 96 degrees, or I guess, no, yeah, 80 degrees positive would be in the eastern hemisphere. So I have no idea where that's going to be, right? Maybe in the middle of Russia or something, right? So when I tried to print it out to prove to you that this actually worked, what did I get? That old address ID. Right? So go back to the drawing board, cut, paste all this stuff, and move it all to moved Lincoln, moved Lincoln. Should I be doing this? No. If you find yourself ever copy pasting, remember the DRY principle. Don't repeat yourself. If you've got repeated code, put that into a function or a method, in this case with Java. Right? I want a method that takes this object and converts it to a human readable string. Right? I want it converted to a string, human readable, and I want to convert this object to a string. Right? And so I'll go ahead and, I don't know, we can return this.name concatenated with, you know, %f. Ooh. Okay, so I probably want to use some sort of printf instead, right? The way that I'm going right here is going to be a lot of concatenation. This.latitude, and then concatenate a comma, space, concatenate this.longitude. This is getting tedious, right? Forget this. Right? So what I can do is, I can't do system.out.printf, because what that would do is that would print it out to the standard input. It would end up not returning anything. So what I can do instead is use the string version of printf, right? Which is, I think that there's printf. Let's find out. This.name, I would just print s and return this. Otherwise, nope, it's called format, right? Just to be different. I don't know why they well, I guess they don't call it printf because it's not actually printing anything. It's formatting it and giving you the string to do whatever you want with it. Print it, ignore it, print it to a file, send it over the wire because you are transmitting to another computer, whatever you want to do with it. All right, let's go back over here and see that, okay, now I don't have to do this cut and paste anymore. All I have to do is print out moved Lincoln. And what that will do is it'll print out the name. I want everything, though. I want the latitude to 2 decimals of accuracy, the longitude to 2 decimals of accuracy, and we can put GPS ID, %s for the GPS ID, this.latitude, this.longitude, and this.GPS ID. There we go. And that'll print it out in a nicely little formatted manner here. Lincoln Municipal, and then 40 degrees north, 80 degrees east now, and LNK. Okay? And now I have a very convenient way of doing all of them. I don't have to print out get name, get GPS ID anymore. All I have to do is print out the object itself, which automatically calls the toString method. And there. You can see the original still has its correct longitude, but the copied version has its incorrect longitude. Right? It's moved longitude. Okay. By the way, I did that because I wanted that formatting. Of course, you could always, I'll get rid of it for a second. If you didn't want to type anything, what could you do again? Source, generate toString. All right, well, what did you want to print out? Oh, I only wanted to print out the name and the latitude and longitude, not the GPS ID. All right, go ahead and generate that for me. Right? And unfortunately, it's not very well formatted, but it gives you something. It gives you a starting point, right? And it looks something like this, right? Airport name is equal to, latitude is equal to, longitude is equal to. Right? So as a first draft, as a first very rough draft, you can have it auto-generate that code for you. Right? But of course, if you want customized or much more readable formats, then you're probably going to have to write your own. You're going to have to roll your own. Right? Okay? All right, good so far. Let's review what we looked at. So in Java, encapsulation is achieved with the visibility keywords. Right? So one of the visibility keywords is private. Achieved. There we go. There we go. I before you except achieved. There we go. Private means that only the class and instances of the class can see the variable, right, and thus change it. There are other keywords. There is also protected. And again, this I don't want to get into this too much because this is inheritance, which we're going to look at later on. Only the class and its subclasses can see the variable and thus change it or access it or whatever you want. The other one is public. Only anyone, any piece of code can see the variable. And like the all-seeing eye of Sauron, if it sees you, it can get you. It can change you, right? It can mutate you. So generally, we don't want that, right? Generally, you should make all variables private unless there is a very good reason. Reason. So in other words, a VGR to do so, to do otherwise. You like, or you should like, immutable objects. You should like having very fine-grained control over the values that it sets. You should like stability. The reason that you want to do this, again, is not only just immutability and thread safety, but testing. If you have a variable, making them public essentially makes them all, every single variable into a global variable. And globals are evil. Why? Because if you've got a global and any piece of code can change it, you need to plan and test and design around the idea that anything will change it. Whereas if you make it private, you have a guarantee. You have a design guarantee that nobody can change it. If nobody can change it, that's much more predictable. It is much easier to test because you don't have to write so many tests. You don't have to make any tests that say, well, what happens if somebody sets the longitude value to negative 5,000, right? Then you don't have to have that test because it's private, right? And nothing would ever compile. The compiler would catch that right away, right? Okay, great. Let's see, what else? Okay. That's pretty good design so far. Now we want to extend our airport a little bit. One thing that I want to do is say, I don't know, what's the address of Lincoln Municipal Airport? I want to send them a letter. Right? I want to send them a bill for I don't know, whatever you might want to send a bill to an airport for. Whatever. An address. So what is an address? A street, right? Which is maybe a string. 1234 North 11th Street, right? What else is an address? city. We'll go ahead and go with state, and then zip. Right. So yeah, those are all reasonable. Except, what is this class again? This is airport. Is an address an airport? No. Houses also have addresses, right? Other buildings that are not airports have addresses. So if I've got four things that logically or conceptually make are grouped together, then what should I be using? I should be using encapsulation. Again, I should be making another class. Right? So let's go ahead and get rid of this stuff. Let me create another class. What should I call this class if it's going to model an address? Good. Call it what it is, right? Put the what it says on the tin, address. Right? Not addresses, because it's not one. I mean, it's a blueprint. You can create multiple addresses after you've designed this class, right? Let's see, private string street, private string street state, private string city, city state zip. There we go. All right, well, bear with me while I type all that stuff to make a constructor, make a bunch of getters, make a toString method. Should I be typing again? Nope. I should be doing what? Source, generate constructor, source, generate getters. And instead, I want to make it immutable. I've convinced myself, yeah, okay, immutability is a good thing. Select all the getters, generate just the getters, and finally, source, generate the toString method, and everything, yeah. Right. There we go. That's good enough for now as a rough draft. I'll come back later and reformat this so that it's not printing out address and then street equals, city equals, etc. It'll format it in a way such that if I printed it out on a piece of paper, I could cut that out and put it on an envelope and it'd work, right? So maybe something like that. So let's go back over here to airport. And now that I've got an address class, private address, address. Right? Note the difference there, the capital A versus the lowercase a. This is the variable name. This is the type. You've seen this before. You had a variable, a member variable, that was another class. String is a class. It's not one that you wrote, but it is a class that's provided as part of the standard Java library. Right? This is called composition. Right? So, composition. Use composition to its fullest. Right? That classes can have other classes, or it can have instances of other classes as member variables. Right? This is called composition. One object is composed of another object. In fact, airport is composed of several objects. In particular, it's composed of an address object. An address object is also composed of objects. It's composed of 4 strings. Right? And that composition relationship can follow as many times as you want. Right? Anytime that you have a has a relationship, right? Composition defines a has a relationship. That an airport has I'll put it, an address. Oops. There we go. A person has a name, but a name, well, if you break it up into first name, last name, middle name, surname, title, right? Maybe if you're getting that complicated, then maybe you want a name class. I would advise against it. That would be far over-engineering, right? There's a nice, there's another nice acronym that you should get to know, YAGNI, right? So take care not to over-engineer your objects. Right? Example, a name object to hold a half dozen strings. Right? Last, first, middle, other middle, title, all right, the suffix, etc. Right? That's kind of overkill. Right? If you need that in your business logic, like if the business needs come to you and say, yes, we need to support all these things, right? Then go ahead and, okay, well, we'll have to design it there. But until somebody comes to you and says, yes, we need this stuff, YAGNI. Does anybody know what that stands for? You ain't going to need it. Right? That's where YAGNI comes from. You ain't gonna need it. And if you want to be grammatically correct, you aren't going to need it, right? But then that introduces a T somewhere in there. YAGNI, and that's not gonna, that doesn't roll off the tongue just as well. YAGNI, you ain't gonna need it, right? So, and it's also kind of, using ain't is gonna kind of flippantly to the business needs. Yeah, okay, sure, we'll go ahead and do that. And then we go back to the team, yeah, you ain't gonna need it, right? Don't waste your time doing that, and then they'll forget about it in a week. And then only if they complain after that, then we'll go ahead and go back and fix it. Right? Only if you design graphical user interfaces all the time with, here's a dangerous operation, right? Here is a operation that's going to cost you some or time, money, resources, or whatever. Are you absolutely sure? Yes or no? Right? That kind of back and forth is kind of one of those dialogue buttons, right? Do you really want this? Right? Well, okay, if you remember that you requested this next week, then we'll go ahead and do it, right? That's the yes button. Otherwise, just cancel and don't do it, right? You ain't gonna need it. Right? YAGNI. Okay, good. So far, so good. We've talked about composition. We've talked about encapsulation. We've talked about, now we need to talk about abstraction a little bit. So, up to now, our objects, that is, again, classes, are mere data containers, right? Or data holders, right? So look at this airport. Does it do anything? It's just there, right? There's no function. There are methods in here. There are several constructors. There are several getters. There's even a toString method. But beyond that, there's no functionality in here, right? It's just a data container. It just contains the name, the GPS ID, the latitude and longitude, right? Oh, yeah, go ahead.
How would you access the value of address from
Good question. I would go back and, all right, laboriously, public address, get address, or, return this dot address. Or I would have gone back up and said, generate that getter for me if I went back and added 5 things, right? So typing or clicking. Right?
So address is a member of airport.
Right.
So from the main you have to dot airport dot address.
Oh, that's a good point. So let's find out. In the main, I want Lincoln's address because I want to print it out. System.out.println Lincoln. If I just print out Lincoln, then I'm going to get what I had before, right? Lincoln Municipal Airport, no address here. So what I'm going to do is you do have to use a getter dot get address, and then you can print that out. Of course, I've not instantiated it yet, so it's going to be null. Right? So back to the drawing board. I can create a constructor that also takes an address, right? Let's go ahead and do that really quickly. Right? There, and then add address, right? And then, again, this dot address is equal to address, right? Or I could have, designed my stuff up front and then just clicked a couple buttons that took everything for me. Now, when I create that over here in the airport demo, then I would have to also create an address object. Lincoln address is equal to new address. And I don't know where it is, but 123 North Street. I do know that it's in Lincoln, Nebraska. I have no idea what its zip code is, so 68116 is the zip code for this building. We'll just go ahead and appropriate that. And then I can, I need to do that up here, by the way, sorry. Move it up here. And then what I can do is I can call that constructor and pass in this address, or Lincoln address. There we go. And now when I print this out, it's no longer null. It's 123 North Street, whatever. I can incorporate that into my toString method, right? I could say that instead of printing it out, printing just this stuff out, then I can go ahead and to do, again, I'm not going to do it because I'm lazy, to do incorporate the address here. Right? And I'll come back and do it later. Right? Yeah?
So I had a question regarding the constructors. If you have multiple ones that are the same name, how do you differentiate between them when you're calling them?
You don't. You let the compiler do that for you. For example, over here, how do you differentiate which constructor actually gets called? Let me go ahead and expand this out. Well, over here, the constructor that took 5 arguments, the first 2 being strings, the second 2 being doubles, and the 5th one being an address, it knows, though I'll call that one over there. It knows that, well, this is the 4-argument constructor. Right? The compilers are dumb, but they can at least look and see how many parameters did you give me, what are their types, and is there a constructor that matches that? Yes, there. Otherwise, compiler error, and I can't compile. Right? You let the compiler do it. That's called static dispatch, which is something that we'll talk about later with polymorphism. Right? Okay? Good. All right, so actually, before we go on to this other part here, let's do one more object. Right? Just as an example here of private date, right? Date built. Right? This is just to, I'm not actually going to implement this because I want to illustrate yet another design principle to you. Remember problem solving. What is the first question you ask yourself when you're faced with a problem? Is it already solved for me? Right? So what's the first question you should ask yourself before designing an object? Is it already done for me? Right? If you want a date, yeah, sure. You don't have to create your own date class and put into it, you know, day, month, year, and then all the constructors, and making sure that there's no such thing as February 30th, and making sure that that it has all this functionality that you date 1 plus 5 days is a different date, and you can get that out, right? Instead, what did you do in lab? Do you remember on your first lab? There is a local date object that is provided by Java. It's in the java.time library, right? java.time.localDate. Right? So, again, when you're designing your object, the first question you should you ask yourself, oh, I need a way of doing dates. Is it built into the language? Or is it built into a standard library that I can bring in and use? Is there an address in the Java library? The answer is no. So once you've got your no answer, then okay, then I'm going to have to make it, right? But if the answer is yes, just reuse it. Why reinvent the wheel, right? Don't repeat yourself. What would it be? Don't rewrite yourself. Yeah, it'd still be the dry principle, right? Don't repeat yourself. Don't rewrite yourself. Don't reinvent the wheel. Okay. All right. So back to what I was going to do. Up to now, our objects are mere data containers, right? That they just contain data. This one doesn't do anything, right? It doesn't compute anything. It doesn't do any number crunching or anything like that. What I want to do is I want to compute the air distance between Omaha and Lincoln. That's some non-trivial functionality. That's going to take the latitude and longitude of Lincoln and the latitude and longitude of Omaha and compute the air distance on the Earth's globe, right? Just as the crow flies, not driving distance. That would be different. But I want an air distance between the two. So what might that look like without object-oriented programming? It would look like a function, right? In fact, you all did this. If you took 155E last semester, you all did public double. You didn't do public. You did double get air distance, right? And you did it between a latitude A, double longitude A, double latitude B, double latitude or longitude B. Right. Now, does anybody remember the formula for that? All right, good. I brought it up. This is the spherical law of cosines, or spherical law of sines, I believe. Yeah, spherical law of sines. It's arc cosine and then all this stuff. So bear with me, but as a review, there's no way that I can go up and generate code for this, by the way. That'd be great if, but no, that wouldn't be great. If there was a button to generate all the code, then none of us would have any careers, right? We still need a way we don't have a way to automate code. The second that we have a way to automate code, now we're in the world where we have to be aware of the machines coming to kill us all, right? All right, so latitude, longitude, what I'll do is I'll return. How do I get arc cosine? That sounds like a math function. Where might that be? Math dot a cosine, right? Remember, everything in Java is a class or belongs to a class. A cosine belongs to the math class. I think, nope, this is the one argument code. Math.sine, sine, times math.sine. And what are those again? I forget. Phi1 is the latitude of location A. Phi2, what was it? Is the latitude of location B. Okay. So I've got the first part, and then plus math.cosine of something that's probably going to be same stuff, right? Latitude and longitude, and that shouldn't be arc cosine. That should be cosine. Times math.cosine of latitude B. Keeps trying to change this on me. Hopefully yours is not doing that. Times math.cosine of, and then this delta. What was delta? Delta is the difference between the longitude and A's longitude. So let me go ahead and make this easier on myself by creating another delta and A minus B? B minus A. All right. And this is also not going to work. Why? What do all these cosine, sines, arc cosines, what are they going to assume? Oh, delta. They're going to assume radians, exactly. And if I'm measuring in 90 degrees north, I need to convert that over to something, right? So, again, the nice procrastinator to do, make a conversion to radians. Right? All right, but otherwise I've got this now. This is what it might look like if you don't have object-oriented programming. Do you see, just within this code here, do you see anything that looks like an object, that looks like an airport at all? You just have latitudes and longitudes, a bunch of doubles, right? So let's make it a little bit more object-oriented, just a little bit, and then we'll go full bore. Public double get air distance of airport A and airport B. This is a little bit more object-oriented in that we're not just passing in these generic numbers that could be anything. We're actually passing in objects. Here's an airport and here's an airport. I want the distance between them. Right? Well, if I've got this function up here, I could just reuse it, right? Return get air distance between A dot latitude, get latitude, B dot get latitude, A dot get longitude, B dot get latitude, B dot get longitude. Right? So nice code reuse, a little bit more object-oriented. What are you complaining about? Get air distance. Oh, airport distance. No, still got to complain. Spelling and pronunciation. Right? There we go. Okay, that's a little bit more object-oriented. At least there are objects now. But it's not good, right? It's not great object-oriented programming. This functionality acts on data inside those classes. Think about what I'm doing here. I've got this airport and I've got this airport. What do I have to do to actually compute something about it? I have to rip this airport open, pull out these two values, and hand them off to another function. I have to rip open this airport, pull out its two values, and hand them off to another function. Right? I don't want to know about the internal workings of that object. I don't want to rip that object open just to compute something. Right? So that's where number 3 of encapsulation comes in. The grouping of functionality, methods, that act on that data. So if you've got a getAirDistance function that computes the distance between two airports, where should that function be? Should it be outside in this demonstration class? Nope, it should be inside the class that it acts on. This is all the data that it acts on, this latitude and longitude, that's inside the class. Therefore, anything that acts on that data should also be inside that class. Okay? What do I mean by that? Well, we'll give it some functionality now. Public, double, getAirDistance. Right? And then question mark there for now. Right? Inside, I've got access to, say, this dot latitude and this dot longitude, right? I've got access to those two variables. But what about the other airport? That airport. How do I get access to that? This is, say, Lincoln. How do I get access to another airport? That's where I pass it in. Right? Airport. And again, I'll go with that for now. Did I change that? Okay, there's still that up here. Okay, we'll come back and change that because that's not a great name. Okay, that would be like destination B or destination, right? That would be a better name, destination. There are only two things difficult in computer science. One is cache invalidation, and the other is naming things. So I'll call it that for now, and then I'll come back and fix that because it's difficult. I don't know what to name this thing. Right? All right. So I've got this airport and that airport. So I've got that dot latitude, that dot longitude. And all I need to do now is bring over this function, right? And change everything. There we go. So that latitude, longitude, let's see, this would be A, so this would be this dot longitude, and then that dot longitude, the difference there. This dot latitude is going to be A. It doesn't really matter what order you go in because if you go from point A to point B and then just in reverse, it's the same distance. As long as you're consistent about it. Latitude, and then that dot latitude. There we go, that's fixed, and I've got my delta. Oh, you know what? I did forget one thing, didn't I? Again, well, I forgot two things. I remembered, oh yeah, I have to go back and change it to radians, but also there's this r over here, right? There, r is the radius of the Earth in kilometers. So we have to multiply by r times r. Radius of Earth. Don't just call things r. If you have a mathematical thing and you're typesetting it like this, yeah, sure, r is fine. But if you're coding is not necessarily math. Coding is, the purpose of coding is to tell not only a computer what your intent is, but also to tell other humans what your intent with writing this code is. If you just have r, some generic r, I don't know what that is. We all know what pi is. We all know what e is because those are universal constants. But r, now call it radius of the Earth, right? Or of Earth. Or Earth radius, or whatever you want to call it. Okay? Now that doesn't exist just yet, and I need to put in my to-do, fix this, convert to radians first, right? Okay. But what I do want to do before I do this, well, I have to fix this first. So where does this variable belong? Here's my first attempt. Double radius of the Earth. Does anybody know what the radius of the Earth is? 6371. All right. Yeah, everything's going to be in kilometers. Don't write code in English, right? Don't write code in English units, right? That's what that Mars probe that crash landed into Mars. It was because one was using English units and another was using the correct metric units, and there was no conversion back and forth, and it just careened right into the surface of Mars. Right? Tens of millions of dollars wasted because somebody, for whatever reason, decided to use English units. Right? There's my radius of the Earth. Should that be a local variable? Think of what happens to the call stack every time this happens. A new variable is created, assigned a value of 371, and then that variable is destroyed when the stack frame goes away. Should I be creating that variable every single time I call this function? Probably not. It's also a constant. Right? I don't want that to change. The Earth's radius is not going to change unless some catastrophic failure happens. Right? That, by the way, that's the average radius. It's not a perfect sphere. It's a little bit oblong because of its rotation. But 6371 is a good estimate. So I'm not going to put this in as a local variable in the function. Let me go ahead and put it up here. All right. Now there's only one of them? Nope. I just transferred the responsibility. Every time an airport is created, Lincoln Airport, Omaha Airport, O'Hare Airport, they're all going to have a copy of this variable. Right? So what I want to do is now I want to go back to one of the original keywords that we talked about and make it static. That means that it doesn't belong to instances of the class. If I've got 3 airports, there are not 3 variables called radius of the Earth anymore. There's only now one variable that belongs to the class itself. The way that you would access that, of course, is like this, but airport is better. Airport dot radius of Earth. That looks familiar. Math.pi. A static double variable called pi was created and set to 3.14. Do you think you can change the value of pi, though, in the math library? No. They made it public so that you could access it, but then they also made it final. So in C, how did we make a constant? Do you remember the keyword for constant? Const, right? You can't change it then. With Java, by the way, Java does have a const keyword. It's in magenta right there. It doesn't do anything, which is why it doesn't know what it is, but it is reserved. It is a keyword in Java. It doesn't do anything. Right? Final is what you want. Final means that you cannot change the radius of the Earth later on. If I try, say, I don't know, over here, radius of the Earth is now only 10 meters, right? We shrunk it down. I don't know, whatever the Schwarzwälder, Schwarzwald radius, right? You can crunch, that's the radius that if you crunch some mass down to a certain radius, then it creates a black hole, right? I don't know what our say it again. Schwarzschild, thank you. Schwarzschild radius is, but certainly, I don't know, our mass of the Earth would be 0.0001. That's certainly enough, I hope, right? I don't want to do that. I don't want to collapse the Earth into a black hole, and it's not letting me do that. Why? Because I made it a constant by using the final keyword. Now, as the last thing of the day, let's come back over here and see if it works. I want to compute the air distance between Omaha and Lincoln. How do I do that? Omaha dot get air distance. Now there's this function that I can call that I don't have to worry about latitudes, longitudes. I don't have to worry about opening up, ripping it open and pulling out the latitudes and longitudes. I just have to give it another airport. All I have to do is reason about objects now. What is the relationship between this object and this object, the air distance? Right? And I can put that into a variable, double dist is equal to, and then system.out.println dist. Right? How far should it be? From Omaha to Lincoln, like 60 kilometers maybe? I'm not sure. Of course, we're not going to get 5,827 kilometers. That doesn't sound right. What's wrong? It's radians. I'll take care of that offline before I post this, and we'll pick it up there next week. But not on Tuesday. On Tuesday, we have special guests coming in. I do this every year. We're going to talk about drafting. We're going to, not drafting as in drawing an architectural design, drafting as in writing, right? writing a technical document, writing an essay, or even writing creative stuff, it all has a very, very close connection to actually writing code because you're doing the same thing. You're writing. And you follow the same process. You do one draft. Oh, there's a bug. I need to go back and fix that draft. I wrote 50 lines of code when I could have written 5 lines of code. It works, but go back, redraft it into something better design, and we'll talk about all of that on Tuesday.